All right, let's start with our within Subjects ANOVA. Within Subjects ANOVA is denoted by everybody belongs to every single group. Let's take a read at this. Dr. Rickert wonders whether students in her SRM2 class might do better on her exams as they get more experienced in taking them. To do this, she compares students' scores on the 3 exams she gave them during the semester. There are 25 students in her class. Fill in the blanks for the following within Subjects ANOVA. Alright, let's start off with total sums of squared. We know that's going to equal exam, which is our independent variable, plus subjects, which is our participant, and error. So in order to do this, we need to do how many exams there were. Much like we had previously when we were filling out our ANOVA table, we are going to be doing the same thing here. We're going to have how many different exams. So it's going to be 3 minus 1, so that'll be 2. The number of participants was 25, so we have 24. Our error is going to be this times this. And then our total is still going to be the total data. So we're capturing 75 data points because there are 3 exams and 25 students taking each exam. So it'll be 75 minus 1. So this will be 74. Our mean square still going to be sums of squared divided by degrees of freedom. Our F is going to be our mean square divided by our error. So we end up with a really tiny F value. By looking in our table, we use the degrees of freedom within error as 40 because 48 is closest to 40. And then we look at 2 for our degrees of freedom between. So we will end up for a 0.05 at 3.23. We therefore know that we would not conduct a post hoc unless we are explicitly told to, or an effect size. Let's take a look at the next questions. Is this a between subjects or within subjects? This is within. We conduct a within ANOVA. Dependent variable scores on exam. The independent variable is class or time taking. Null hypothesis, all scores will be equal. Not all will be equal. We would conduct a Tukey's to see how to conduct the Tukey's the same way as before. So we look up our Q value in our table. It's going to be .53. We have our MS within, our MS error, 381.6, and our little n, which is how many people are in the class, 25. can equal this times the square root of the mean squared error divided by our sample size. So we're going to end up with 13.317. However, since we know that there was no significant difference, we don't need to do anything farther than calculate what our HSD would be. Next, we're going to calculate the effect size. In this case, it's sums of squared between divided by sums of squared between plus sums of squared error. So we end up with a very tiny 0.014, but again, this wouldn't be relevant as we are not supposed to be conducting an effect size. Alright, if we were to write out a results section, it would be something along the lines of this. A within subjects ANOVA was calculated with score as the dependent variable. The effect was not significant. We take the 2 degrees of freedom, the 48, close parentheses, equals our f, which was 0.36, p is greater than 0.05, we'll call it eta squared equals 0.015. But again, we don't have to calculate that unless it's actually significant. No post hoc was necessary as the results were not significant. That is all for our within subjects ANOVA. Take care.